Ever wondered how the world's most advanced warship, a $13 billion floating fortress, moves across the ocean? The USS Gerald R isn't just a ship, it's a city, a weapons platform, and a mobile airbase all at once. From tugboats inching it out of dry dock to launching stealth jets mid-transit, every movement is precision-engineered. Millions of man-hours, nuclear propulsion, and cutting-edge technology make moving this supercarrier a spectacle of power, strategy, and human skill. Today, we'll uncover how the US Navy transports, operates, and projects dominance with this floating titan anywhere in the world. 1. The $13 billion giant that refuses to be rushed. Moving the USS Gerald R is not like moving a normal ship. This is a floating city that stretches over 1,100 feet, weighs nearly 100,000 tons fully loaded, and carries the responsibility of American power wherever it sails. Every movement of this supercarrier is planned days in advance, sometimes weeks, because even a minor mistake can cost millions or risk lives. Tugboats don't push it casually. Engineers don't rely on instinct. Every inch is calculated. When the Navy moves the Ford, it moves slower than traffic in a parking lot, but with far higher stakes. The ship's size alone changes how water flows around it, how winds affect it, and how nearby vessels must clear its path. This is why moving a supercarrier is less about speed and more about absolute control. 2. Nuclear power doesn't mean instant movement. People assume that because the Ford is nuclear-powered, it can move instantly with massive force. The reality is very different. Nuclear reactors generate enormous energy, but that power must pass through thrust bearings before it ever turns the propeller shafts. These bearings are among the most critical components on the ship. If they are even slightly misaligned, the entire propulsion system is at risk. That's why when the Ford suffered thrust-bearing issues after delivery, the Navy did not gamble. The carrier was sent into dry dock for one of the most precise mechanical repairs ever attempted on a warship. Moving the ship during this phase meant engines idle, tugboats active, and constant monitoring to prevent further damage. This wasn't about travel, it was about survival. 3. Dry dock precision measured in thousandths of an inch. To repair the Ford, the Navy had to move it into one of the largest dry docks in the world. This process alone is more complex than most naval operations. Tugboats slowly guide the carrier until it is perfectly aligned over support blocks positioned on the dock floor. Over 100 million gallons of water are drained, and as the water level drops, the ship settles onto those blocks with tolerances measured in fractions of an inch. If the hull settles unevenly, structural stress can occur. Once dry, engineers spend months realigning thrust bearings to accuracy levels smaller than a human hair. Moving the Ford out of dry dock after repairs takes days, not hours, with flooding controlled slowly so the ship regains buoyancy evenly. This is naval engineering at its absolute limit. 4. Tugboats, not engines, control the most dangerous moves. When the Ford enters or exits port, its own engines often take a back seat. Tugboats become the real drivers. These small but powerful vessels apply force at precise angles, nudging the carrier feet per minute rather than miles per hour. Wind speed, current direction, and water depth are constantly recalculated. One wrong push could swing the bow into a pier or twist the hull. That's why tugboat operators train specifically for carrier operations. Every command is coordinated between the bridge, harbor pilots, tug crews, and Navy engineers. This choreography becomes even more critical when moving the carrier during deployments, where timing and positioning matter just as much as secrecy. 5. How a supercarrier moves across entire oceans. Once clear of port, the Ford's movement shifts from centimeters to knots, but still, nothing is casual. The carrier cruises with a full strike group, including guided missile destroyers and cruisers that screen threats and manage radar coverage. At around 30 knots, the Ford is faster than most submarines, which dramatically affects how it is hunted or protected. Its movement pattern is unpredictable by design, constantly shifting course to avoid tracking. When deployed, the carrier becomes a moving airbase capable of projecting power hundreds of miles inland without ever touching shore. This mobility is exactly why moving a supercarrier is strategically more powerful than firing a missile. The most intimidating movements of the USS Gerald R. Ford happen when it enters high-tension regions. In the Caribbean, Mediterranean, or near contested waters, the carrier doesn't stop, it positions. It arrives with aircraft already on board, radar systems active, and escort ships forming a moving shield. The Ford can shift from transit to combat-ready posture almost immediately. This is not coincidence. The entire ship is designed so movement itself becomes a weapon. Its presence alone alters enemy calculations, changes political behavior, and sends a signal without a single shot fired. The way the Navy moves this carrier is the message. 6. Aircraft operations while moving. The USS Gerald R. Ford is a mobile airbase, and moving it doesn't pause its most important job, launching and recovering aircraft. The Ford can carry up to 75 aircraft, including FA-18s, E-18G Growlers, and 2 squadrons of F-35C stealth jets. EMALS, the electromagnetic aircraft launch system, allows planes to take off faster and smoother than traditional steam catapults, minimizing stress on airframes while increasing sortie rates by 33% over Nimitz-class carriers. Even while cruising at 30 knots across open seas, the flight deck remains a carefully orchestrated ballet of jets, crew, and safety protocols. Pilots must coordinate with bridge commands, radar operators, and deck crew to launch safely during transit, a challenge complicated by ocean swells, wind changes, and the carrier's immense size. Moving a ship of this scale while maintaining full launch capability is a technical feat few militaries can attempt, proving that the Ford isn't just transported, it operates continuously, projecting power wherever it goes. 7. Training crews during transit. Every movement of the Ford doubles as a training exercise. Sailors continue proficiency drills, including firefighting, emergency evacuations, and technical maintenance, while underway. Even in the middle of the ocean, the crew practices responding to hypothetical scenarios such as flooding, mechanical failure, or simulated attacks. Tugboat operators, engineers, and navigators coordinate complex maneuvers, often with millimeter precision, so that the carrier can maintain its course without interruption. The ship's automated systems reduce manpower for routine operations, freeing personnel for higher-level simulations, system monitoring, and readiness exercises. Training while moving ensures that the crew is combat-ready at any moment, turning transit into an extension of operational preparedness. 8. Strategic movement across oceans. Moving the Ford isn't just about getting from point A to point B. Every crossing of the Atlantic, Pacific, or Caribbean becomes a strategic display of global naval dominance. Escort vessels, including guided missile destroyers and cruisers, form a protective perimeter that extends radar coverage and ensures anti-submarine and anti-missile defenses are continuously active. The ship's speed, currently averaging 30 knots, allows it to evade potential threats while maintaining operational readiness. Satellite reconnaissance, aerial patrols, and global intelligence assets guide its movement, allowing the carrier to arrive in the right place at the right time. Large-scale exercises with allies often accompany these movements, further extending the carrier's influence. Moving a $13 billion warship across oceans requires meticulous coordination between the Navy's fleet operations, intelligence agencies, and logistics teams, proving that even transit is a tactical operation. 9. Moving near hostile waters. When the Ford approaches contested or high-tension zones, every movement becomes more sensitive. Entering the Caribbean Sea near Venezuela, the carrier had to account for coastal currents, shipping lanes, potential aerial threats, and satellite surveillance. Its movement is carefully choreographed to ensure operational security while maintaining combat readiness. Radar and communication systems remain active, monitoring for any approaching threats, while aircraft remain on standby for immediate deployment. Each turn, course correction, and speed adjustment is precisely calculated to protect both the ship and its personnel. Even the slightest navigational misstep could affect flight deck operations, damage aircraft, or expose the carrier to vulnerabilities. This is the ultimate test of naval engineering and strategy, moving a supercarrier not only safely but in a manner that asserts power without firing a shot. 10. Life support and logistics while moving. The Ford isn't just a weapon, it's a floating city supporting over 4,500 personnel. Moving such a massive population requires unparalleled logistical coordination. Meals are automated, pre-cooked, vacuum-sealed, and distributed efficiently using onboard systems, while fresh supplies are delivered by cargo ships even at sea. Water, medical services, and power are continuously monitored. Automation reduces the crew required for these systems, but the human element remains essential for quality control. Every day at sea, sailors experience a well-orchestrated routine of work, rest, and training, all while moving the largest aircraft carrier ever built. Coordinating life support during a movement that can span thousands of miles is a feat that combines engineering, military discipline, and logistical mastery. Every move of the USS Gerald R. Ford is an orchestration of engineering, logistics, strategy, and human precision. From dry dock alignment measured in thousandths of an inch to transatlantic voyages with full aircraft launch capability, the carrier moves with purpose. Its speed, power, and technology, EMALS, advanced arresting gear, dual-band radar systems, make it operationally ready the instant it reaches its destination. It is a deterrent, a projection of American power, and a testament to naval engineering on an unprecedented scale. The Ford demonstrates that moving a $13 billion supercarrier is not simply transportation, it is strategy in motion, ensuring global presence, operational readiness, and combat superiority anywhere in the world. This is how the U.S. Navy moves its most formidable asset, a floating fortress that combines technology, logistics, and sheer human skill. From tugboats to nuclear propulsion, precision dry dock alignment to ocean crossing logistics, aircraft launches to life support, the USS Gerald R. Ford moves like no ship ever built. Every maneuver shows power, precision, and strategy. If you enjoyed this, like, share, and subscribe for more incredible naval insights.